Now we want to use what we've learned about the sum and difference identities to prove some identities. So we want to prove first that sine of x plus pi over 2 is equal to cosine of x. So what this really means is if you add pi over 2 or 90 degrees to any angle, that sine of that angle is equal to cosine. And this is actually our cofunction identity. Okay, so we're going to think of this like u and v. So we're going to start with sine of x plus pi over 2, and we're going to use the sum formula, which is on your formula sheet, to write this as sine of x cosine of pi over 2 plus cosine of x sine of pi over 2. And now what we need to do is look at our unit circle and look at pi over 2. We see that cosine of 0 is 0 and sine is 1. So we can plug those values in. We've got sine of x times 0 plus cosine of x times 1, which sine of x times 0 is just 0. So we just get cosine of x. So we use the sum identity to solve that, or to prove it. Okay, next we want to show that sine of alpha minus beta over cosine alpha cosine beta is equal to tangent of alpha minus tangent of beta. So we're going to start with this left-hand side, sine alpha minus beta over cosine of alpha cosine of beta. So we're first going to use the identity for sine of alpha minus beta. So we can rewrite that as sine of alpha cosine of beta minus cosine of alpha sine of beta over cosine alpha cosine beta. Okay, the next thing we can do is separate our fraction. Okay, now since we're subtracting in the numerator, we can write this as two pieces over the same denominator. So we can break this up into sine of alpha cosine of beta over our denominator minus the second piece, cosine of alpha sine of beta over cosine alpha cosine beta. Now notice for this first piece, the cosine betas cancel out. So we'd have sine of alpha over cosine of alpha minus the second piece, the cosine alphas cancel out. Sine of beta over cosine beta. Okay, and since from the quotient identity, we know that sine of x over cosine of x is equal to tangent of x. So this would be tangent of alpha minus tangent of beta, which is what we were trying to prove.